Let us study today about inequality, a topic about inequality, and we will discuss today about basics of inequality. Basics of inequality. Actually, in real numbers have a property that they are comparable. There is a property of comparability in real number. Comparability process means if x is a real number, y is another real number, then either x is greater than y, or x is less than y, or x is equal to y. Three possibilities are there. This condition is called equality. This condition is called equality. If two real numbers are equal, this condition is called equality, and these two conditions are called inequality. These two conditions are called inequality. And this law is called law of trichotomy. This law is called law of trichotomy. Law of trichotomy says that if x and y are two real numbers, then either x is greater than y, or x is less than y, or x is equal to y. Three conditions are there, three possibilities are there. There is no any other possibilities. And real numbers hold this property, and the complex number or imaginary number does not hold this property. For example, if I say that 3 plus 2i and 1 plus 2i, we cannot compare these two complex numbers. There is no property of comparability. We cannot say that this is greater than. No, this is wrong. Imaginary numbers or complex numbers does not have property of comparability because they are imaginary. We have imaging, and so we cannot compare to nonsense type numbers, complex numbers. So only real numbers hold this property that according to law of trichotomy, either x greater than y, or x is less than y, or x is equal to y. Now, if x is a real number, then x square is always greater than or equal to 0. If x is a real number, you can take any real value of x square is always greater than or equal to 0, means either it is 0 or it is positive. Either it means either x square equal to 0 or x square is greater than 0. Such type of inequality where there is also equality sign is called slack inequality. This is called slack inequality, where inequality symbol and equality symbol both are there. So this type of inequality is called slack inequality. For example, we should know if x and y are two real numbers, then x square plus y square is always greater than or equal to 2xy. For two real numbers x and y, x square plus y square is always greater than or equal to 2xy. So this condition is called slack inequality. And there are some other properties. Let us discuss about them. For example, 1 minute. If for any real number x square plus 1 is always greater than or equal to 0. This number is always greater than or equal to 0. Sorry, not greater than equal to, always greater than 0. X square plus 1 is always greater than 0. This type of inequality where there is no equality sign is called strict inequality. This is called strict inequality. This is called what? Strict inequality, where there is no equality sign. X square plus 1 is always greater than 0 for any real number x. Okay, now let us discuss about some properties. Besides real number, expressions, algebraic expressions or other numerical expressions are also comparable. We can compare them. Let us discuss some properties now. Properties of inequality. Properties. So, properties are if A is greater than B and if C is greater than D, these are two inequalities of same nature. Same nature means there are greater than symbol, there are greater than symbol. So we should think about whether we write like this or not. A plus C greater than B plus D. Whether this is right or wrong. A minus C greater than B minus D. This is right or wrong. A multiplies A into C greater than B into D. This is right or wrong. And A divides C greater than B divides D. This is right or wrong. We should think about them. Here, if C is not equal to 0, we cannot take denominator as 0. So if C is not equal to 0, then A by and D also. D is not equal to 0. So A by C, if A greater than B, C greater than D, then can we write like this? Can we add them? A plus C greater than B plus D. So by thinking different examples, you will find that this is true. We can add two inequalities of same nature. This is true, yes. A plus C, if A greater than B, C greater than D, then A plus C is always greater than B plus D. For example, if 3 greater than 2, 4 greater than 3, we can add both of them. 3 plus 4 will be greater than 2 plus 3, means 7 greater than 5. Yes. So we can add two inequalities of same nature. We can add, but can we subtract also? Can we subtract also? For example, if we subtract here this inequality from this inequality, so 3 minus 4 and 2 minus 3. 3 minus 4 is minus 1 and 2 minus 3 is also minus 1. So according to our condition, it should be greater, but here it is equal, not greater. Here it is equal, not greater. So we cannot subtract two inequalities of same nature. Means this property does not hold. We cannot subtract two inequalities of same nature. For example, let us take another example. 2 is greater than 1 and 3 is greater than 2. If we subtract, again same, so 1 minute. 4 is greater than 3. If we subtract now, minus 2 greater than, and here also minus 2. Both are different because we know that they both are equal. They are not, there is no inequality sign. They are not greater. Let us discuss about multiplication now. If we multiply two such inequalities, then what will we get? For example, if you multiply like minus 2 greater than minus 1 and minus 3 greater than minus 4. If we multiply these two inequalities, minus 3 into minus 2, minus 2 into minus 3, and it is greater than minus 1 into minus 4. So this is 3 to the 6, 6 greater than. So if we take minus 1 greater than minus 2, if we multiply both of them now, means minus 1 multiply minus 3, minus 1 multiply minus 3, and here minus 2 multiply minus 4, we will find that minus 3 into minus 1 will become 3, and here 4 minus 2 into minus 4 we will find 8, 4 2 is 8, and we see that if we multiply these two inequalities of same nature, we are finding that 3 greater than 8, and we know very well that this is not possible, this is wrong. 3 is not greater than 8. Means again multiplication fails, means we cannot multiply two inequalities of same nature. We cannot multiply. Now let us think, can we divide? Can we divide them? For example, let us take this example. Same example. If we are dividing these two inequalities, so we will get 1 by 3 here, and here we will get 2 by 4. So is 1 by 3 greater than 2 by 4? No. If we cross multiply them, we will find 4 1 are 4 and 3 2 are 6. Not greater than means we cannot divide two inequalities of same nature. I want to say that two inequalities of same nature can be added only. If A, B, C, D are unknown, then we can add two inequalities of same nature. We cannot subtract, we cannot multiply, and we cannot divide. Now, if we take another condition, if we take a condition like if A greater than B, C greater than D, and A greater than B, C greater than D, and both are positive also. They are positive also. And if C greater than D and they are positive also, then need not to think about A plus C greater than B plus D. It is universal truth. It will be true. But again, A minus C greater than B minus D. If both are positive, can we subtract them or not? Let us discuss. For example, 3 greater than 2, and here if we take 2 greater than 1. If we subtract now, we will find that 3 minus 2 and here 2 minus 1. So 1 greater than 1, which is not true, because we know that 1 is equal to 1. 1 is not greater than 1, 1 is equal to 1. So we cannot subtract again. If both are positive, even then we cannot subtract two inequalities. Can we multiply now? If both are positive, like 3 2 2 1. If we multiply here, we will find 3 2 are 6. 3 2 and here we will find 2 into 1. So we will find 3 2 are 6 and 2 1 are 2. And we will find that this is true. 6 is greater than 2, yes. If both are positive, then we can multiply, yes. A into C greater than B into D. So we can multiply. Now can we divide also? For example, if we take this example, same example, here if you divide 3 by 2, 3 by 2, and here 2 by 1. So just think whether 3 by 2 is greater than 2 by 1. The correct answer is no. 3 by 2 is not greater than 2 by 1. 3 by 2 is less than 2 by 1. You can check. 3 by 2 is less than 2 by 1. Means we cannot divide two inequalities if A, B, C, D all are positive. If they are positive, even then we cannot divide. Now let us discuss some other property. For example, A greater than B and C greater than D. 1 minute. A greater than B only. If A greater than B, then what can happen? If we add an unknown quantity K both sides, what will be its effect? It is true or not? For every K, this is right or wrong? If we subtract an unknown quantity K for every K, this subtraction is right or wrong? If we multiply, then this is right or wrong? And if we divide A by K, it is right or wrong? B by K. We have to check these 4 conditions whether these are right or wrong. Where we should write here, since K, if K is not equal to 0, if K is not equal to 0. So A plus K greater than B plus K is always true for any two real numbers, for any value of K. And A minus K, B minus K is also true. We can subtract also. We can subtract also to any unknown number K without knowing. Unknown in terms of sign means we don't know this is positive or negative, but we can subtract like this. A minus K greater than B minus K. Can we multiply also? Can we multiply also? Let us take some example to check it. So, if 3 greater than 2, let us multiply both sides by minus 2. If you multiply both sides by minus 2, on multiplying both sides by minus 2, on multiplying by minus 2. If you multiply same number minus 2 means here k equal to minus 2. So we will get 3 into minus 2 and here we will get 2 into minus 2. We will get 3 to the 6 minus 6 and here we will get 2 to the 4 minus 4. Now is minus 6 greater than minus 4? Is it right to write minus 6 greater than minus 4? No, we know that minus 6 is less than minus 4. So here inequality fails. We cannot multiply an unknown number k on any of given inequality. It is not right. We cannot multiply, there may be problem. But can we divide also? For example, here let us divide by minus 2. If you divide by minus 2 on dividing by minus 2, what will we get? K equal to minus 2 here. K equal to minus 2. If you divide them, we will get 3 by minus 2 and here we will get 2 by minus 2. So 3 by minus 2 means minus 3 by 2 and 2 by minus 2 means minus 1. Minus 3 by 2 means minus 1.5 and this is minus 1. So we know that minus 1.5 is not greater than minus 1. Minus 1.5 is not greater than minus 1. Minus 1 is greater. Minus 1 is greater. Here also inequality fails. Means we cannot multiply and divide also. To any unknown quantity k, we cannot multiply and divide. We can only add and subtract if k is unknown. Okay. Right to multiply or to divide any unknown quantity k on both sides of the inequality. But if they are not, if k is not unknown, suppose k is known, means we know that k is positive. If we are taking k as positive, then what can be done? Let us think. If k is greater than 0, if k is positive, if k is greater than 0, then there is no doubt to say that a plus k greater than b plus k holds true. This is right, no wrong. If a greater than b, k is positive, then a plus k greater than b plus k. Need not to think about it. And again, a minus k is also greater than b minus k. This is also right. This is also not wrong. This is also right for every k. But if we multiply any positive k, then what will we find? For example, 3 greater than 2. Let us multiply 5. Let us take k here 5. If we multiply 5 both sides, 3 into 5 and 2 into 5. So we will find that 3 5s are 15 and 2 5s are 10. Inequality holds true. Whether in a previous example we had multiplied by negative number. For example, here if we multiply by minus 5, if we multiply by minus 5, 3 into minus 5, 2 into minus 5, we will get minus 15 and here we will get minus 10. What happens? So, inequalities symbol will become reverse, means minus 10 is greater than minus 15. Means if we multiply by a positive k, then it is true. Inequality symbol means whether if it is greater, it will be greater. If it is less, it will be less. But if we multiply by a negative number, if k is negative, k is less than 0, then we will find a into k is less than b into k. Means inequality symbol change. And same condition if we divide by positive k. If we divide by positive k, for example, here if it is given that 3 greater than 2 and if we divide by 3 both sides, so 3 by 3, 2 by 3. If we divide by positive k, we see that here it is 1 and here it is 2 by 3. We know that 1 is greater than 2 by 3. So this is true for positive k. But if we divide by minus 3, if we take k equal to minus 3, then we see that 3 by minus 3 and 2 by minus 3. Here we see that minus 1 and here minus 2 by 3. Now since 1 is greater than 2 by 3, so minus 1 is less than minus 2 by 3. Minus 2 by 3 is greater. Means if we divide by any negative k, symbol of inequality reverses. Means if it is greater it will be smaller, and if it is smaller it will be greater. So we can conclude that for adding and subtracting there is no restriction. For any k we can add and subtract, and if k is positive then we can multiply and divide also, and if k is negative, for any unknown k we cannot multiply and divide. If k is negative then sign change, inequality sign change. Now let us discuss some other property of inequality. Now there is another type of inequality we have seen, which is called double inequality. Like we have seen 1 is less than 5, less than 7. This is called double inequality. Now let us discuss about some other property. For example, if mod x is less than, for any real number a, positive real number a, if a is a positive real number and mod x is a, this is possible only when x is less than a and x is greater than minus a. This is possible only when x is less than a and x is greater than minus a, then mod x is less than a. For example, if you plot a number line, let us take a as 5. So if mod x is less than 5, this is possible only when x is less than 5 and x is greater than minus 5. For example, if you plot a number line 0, and suppose here minus 1, minus 2, minus 3, minus 4, minus 5, here 1, 2, 3, 4, 5. So it is saying that mod x is less than a, mod x is less than 5. So if x is less than 5, x is less than 5 here, then its mod will be less than 5. It is true. And here if it is greater than 5, then mod x will not be found as less than 5. And here if it is less than minus 5, means minus 6 or minus 7 like this, then again suppose we take minus 6. So we know that minus 6, mod minus 6 is equal to 6, which is greater than 5, not less than 5. So if mod x is less than a, then minus a is less than x is less than a. Such condition. And if mod x is greater than a, then either x is less than minus a or x is greater than a. This condition will be found. Now I think it is clear now. Let us discuss some other property of inequality. For example, if two real numbers x into y is greater than 0, greater than 0 means they are positive. So it is only possible when either both are positive or both are negative. X is less than 0 and the y is less than 0. Means if x into y greater than 0, then either x, both are positive, x greater than 0, y greater than 0, or both are negative, x less than 0 and y less than 0. And if it is very clear, let me explain. For example, if we take 3 into 2 greater than 0, then we know that for 3 into 2 both are positive, it is true. And if we take both negative, like minus 3 into minus 2, then again it is true, because we will get 6 and this is greater than 0. Again we will get. So if x into y greater than 0, then either both are positive or both are negative. And if x into y less than 0, x into y less than 0, then either x greater than 0, y and y less than 0, and y less than 0, or x less than 0 and y greater than 0. Means one number will be positive and one number will be negative. If x into y less than 0, then either x greater than 0, y less than 0, or x less than 0, y greater than 0. I think it is clear now. Okay, so these are properties of inequality. Okay, so that's all.